Okay, so we've got some quiz problems here written over to the right there, but I'll rewrite them here. Okay, first one is we have x cubed plus 3x squared minus 2 minus the quantity x cubed plus 2x. Okay, well, first thing we have to do is we need to distribute the minus through this expression here. That's going to give us x cubed plus 3x squared minus 2 minus x cubed minus 2x. 2 didn't come up. Okay, makes sense? Just like saying minus 1 times all this. So we multiply all these by minus 1. But you can just think the minus sign applies here, the minus sign applies to distributive. Okay, now what do we have? Well, let's pair up the x cubed terms. We're going to have x cubed minus x cubed. And then we go to x squared terms. Well, we just have one x squared term here. And then we have just one x term. Okay, so in general, what you want to do is you want to put all your highest power terms together, then the next power, then the next power, and the next power. Okay? Now, x cubed minus x cubed is just 0. You're subtracting something from itself. That just leaves us 3x squared minus 2x minus 2. And we're done with this one. Okay. So let's move to the next one. We have x squared plus 4. Multiplied by x cubed minus 2x. Now, there are a couple of ways this can be done, but the way that's closest to the way you saw me do it is we're going to say, well, that's x squared plus 4 multiplied by x cubed. And then plus x squared plus 4 multiplied by minus 2x. It's an application of the distributive law. You could also have done x squared times x cubed minus 2x plus 4 times x cubed minus 2x. It's your choice. I saw more of this than I saw this. I'm going to demonstrate this. Okay. Then x squared plus 4 times x cubed is what? Well, the x squared multiplies the x cubed, and the 4 multiplies the x cubed. So we have x squared times x cubed plus 4 times x cubed. And then we have x squared times negative 2x. Times negative 2x. That's negative 2x is written kind of small there. I'm having to write just a little differently, so I'm having to adjust that. No excuse. Since I'm having to adjust, I might write better. Okay. Hard to write much worse. Okay, but bear with me a little bit. Okay, x squared times x cubed. Well, what's that? That means x times x multiplied by x times x times x, right? So x squared times x cubed gives you x to the 5th. And of course, you have the rule. When you multiply the same thing to two different powers, you add the powers. Then 4 times x cubed is 4x cubed. Then x squared times negative 2x is going to be negative 2x cubed. And you can see you've got an x cubed here because you got an x times x and another x, right? going to give you x times x times x, that's x cubed. And of course, the rule, we add the powers, the second power to the first power. X to the second times x to the first is x to the third. Okay, then we have negative 8x. Okay, well, now we see we have 4x cubes and we have negative 2 of them, right? So that's 4 minus 2, or just 2x cubed. So that's x to the fifth plus 2x cubed minus 8x. Okay, makes sense. All right. Now we have 3x multiplied by 2x squared minus 3 multiplied by x squared plus 4. Okay. Two ways you can do this. Now, you have three things multiplied together and you can only multiply two things at once. Okay. So we can write this as just write it again, but put parentheses here and here. So we're going to multiply this by this first. Now, alternatively, we could multiply this by this first. Now, I'm going to do it both ways. So that equals 3x times 2x squared minus 3x times 3. Okay, got to multiply 3x by this and 3x by minus 3. Don't forget to do that. It's easy to do that because you're kind of focused on the first term and you kind of forget to do the second term. Okay, a common mistake. And I've seen a couple of instances where people make that mistake. Okay, so we could do this. Okay, now 3x times 2x squared, but I've gone through all the details of the explanation. That's 6x cubed. And this is 9x. So we get 6x cubed minus 9x multiplied by x squared plus. Okay, well, now we've got to apply the distributive law here. We could do like we did here. I did the x squared plus 4 times this, and then the x squared plus 4 times this. But this time, I'm going to split it up the other way. Let's say this is 6x cubed times x squared plus 4 minus 9x times x squared plus 4. Okay. Same thing, but different choice of the way to split up the distributive law. You need to understand it like this, and you need to understand it like this. Okay. Sometimes you're going to want to do one, sometimes you're going to want to do the other, and you want to have the. So that gives us six x cubed times x squared plus 6x cubed times 4 minus 9x times x squared, and I'm out of room, and then it's going to be minus 9x times 4. Apply this out, we get 6x to the fifth. Here we get 24x cubed. Then we get the negative 9x cubed see if I can make it worse. Okay, and then minus 9 times 4 is negative 36x. And we have x cubed terms. If 4x cubed minus 9x cubed, 24 minus 9 gives us 15, 15x cubed. And the x to the fifth and the 36x are not combined with any other terms, the same. Oh, okay. So there we have that. Make sense? Okay. I haven't left myself enough room to do this the other way, but to demonstrate, I will be sure to do that. So, let's look at where. Yeah, this is one. Okay. So I could do the same thing. I've got 3x. It's 2x squared minus 3 times x squared plus 4. I'm going to put my parentheses here. And I'm kind of blocking my 3x there. Let's try to still that. Let me make that a little clearer. Okay. Bad looking 3, bad looking x, but I think it's what they are. Okay. I want to multiply this out. So we're going to have 3x multiplied by what? 2x squared plus 3 times x squared plus 4. Okay, so I'm multiplying inside here using the distributive law, multiplying 2x squared by this and negative 3 by this. And that gives me 3x multiplied by 2x to the fourth. Now, I'm not skipping, well, no, I don't want to skip a step here. So 2x squared times x squared plus 2x squared times 4 minus 3 times x squared minus 3 times 4. Is that clear? 2x squared times x squared, 2x squared times 4, negative 3 times x squared, negative 3 times 4. That gives us 3x times 2x to the fourth plus 8x squared minus 3x squared minus 12. And now we distribute through by the 3x. And I'm going to write out every step. It gets a little tedious to do that, but when you're first doing these, you really want to show every step. Unless you are totally confident, you see what's going on, you can see the steps in between, and I'm pretty sure you're always going to remember it. So it's 3x times 2x to the fourth plus 3x times 8x squared plus 3x times negative 3x squared plus 3x times negative 12. This gives us then 6x to the fifth, and 3 times 8 is 24, x times x squared is x cubed. And then 3 times 3 is negative 9, x times x squared is x cubed. And then minus 36x. 3 times -12 gives us -36. We still got the x. And now this simplifies to 6x to the 5th plus 15x cubed minus 36x. And lo and behold, this agrees with this. So I actually went through both of these without making any mistakes. So that's got to be an omen or something. Okay. Anyhow, got it. That's the process. Now, if you weren't able to just run through these things in 5 minutes or less, you need to practice them more. Okay. Means you go, I'm not signing that, you don't have to, but if you want to prepare well enough to pass the exam that we have at the end of the semester, and this is going to be on it, then you're going to want to practice more. Okay. You want to practice until this is second nature, until this is real easy. That makes sense? Okay. Now you do have the test in there. I don't think this is on it. Is everybody taking that test? Okay, now we have these special products, as they're called. And these are two of the most common ones. They just allow us to shortcut some of our work a little bit. So let's take the first. X minus a times x plus a. I'm going to say that's x times x plus a minus a times x plus a. Okay. And again, if you said x minus a times x plus x minus a times a, it'd come out with the same thing. Okay. And I'm only going to do it one way. So I'll kind of alternate between the two possible ways. Well, if I multiply this out, I have x times x plus x times a. And then it's minus a times x minus a times a. And most of you don't want to be skipping this step because I'm seeing a lot of mistakes that wouldn't be made if you didn't skip that step. Okay, if you try to skip ahead and get it done quick, you're not being as meticulous as you need to be at this point. Okay. And most of the mistakes I see being made would be remedied if you would write out this step. Again, it's your own judgment whether you actually do that or not, but for the first couple of assignments, I certainly recommend it until you've done a couple dozen of these. Okay, anyhow, x times x is x squared. X times a, now I'm going to take the liberty of writing that as ax, because we usually write the coefficient for a little variable, okay? And x times a is the same as a times x. And then it's minus a times x. And then it's minus a squared. Now we simplify that, and it's pretty clear that ax minus ax is 0. So I get as x squared plus 0 minus a squared. Just x squared minus a squared. Okay. Okay, well. Right. X plus a times x plus a. That's going to be, I'll write it this way, x plus a times x plus x plus a times A. Just separate it kind of over this plus sign. Okay, instead of this one like we did here. And then that's x times x plus a times x plus x times a plus a times a. That's x squared plus ax plus ax plus a squared, and ax plus ax is x squared plus 2ax plus a squared. Okay. So now we have two what we call special products. So we can kind of write these results. Now I wrote x plus a times x minus, but it doesn't matter in which order you write these. Whichever order strikes you, and that order happened to strike me here. So you could see it this way, or you could see it this way. And I'm not even sure which way open math does it, probably this way. So that's one special product. These are called special products. And x plus a squared, because that's what x plus a times x plus a is, right? Well, there's two patterns that occur often enough that we do a special section on them, okay? And there's a couple other patterns. There's one for x plus a cubed and x minus a cubed, okay? But in this course, we're probably not going to deal with it, okay? You might see them in some of the open math materials. It's easy enough. If I wanted to cube it, I'd have to write another one. Then I'd have to figure out which two to write first. Well, I get x plus a times this. And it's pretty easy to do that. Okay, well, what good are these? Tell me. I don't have room to write it here, so it's over here to this board. Okay, so we have the two special products. Now let's say we got four z plus 3q squared. Okay, I can use this pattern. This is like x plus a squared with x equal to 4z and a equal to 3q. Okay. In other words, if I replace x with 4z and a with 3q, I get this. Well, using the special product, x plus a squared equals this, it follows that if I replace all my x's by 4z and replace all my a's by 3q, well, do that, okay? Replace x by 4z, both here and here and here. Well, that's 3 times. And replace a by 3q, here, here, and here. So write out this step here, but do the replacement. Do the substitution that we see here. Not sure where to start? Well, first you want to write this out. You want to replace x, every x with 4z. Okay, so let's see if you can do that. And I'm not going to give you a lot of time. I'll come up here and do it pretty quickly. We'll see. Okay, most of you are doing pretty well with this, although I'm seeing little mistakes and omissions. Okay, well, that's not surprising. You probably haven't seen anything like this before, so that was good. I think everybody has somewhat the right idea. But let's focus on the details, okay? So we're going to replace x by 4z. So we have an x here. We look up here, x is 4z. So we write 4z where we had x. And then where we had a, we're going to write 3q. And then we're going to keep our parentheses and it's still squared. And I don't have room to squeeze the thing in here, so I'll come down here and wrap around the second line. Okay. Now I have an x here and it's squared, right? So I better replace that x with 4z. So instead of x, I write 4z to the square. Now that's not quite right because x is getting squared. Whatever I replaced x by is got to be squared. And that means I've got to square the whole 4z. So I got to put parentheses around that or I'm going to end up with the wrong expression. Okay. And then 2ax, well, let's see, a is 3q. X is 4z. Okay. And I'm going to try to squeeze in my a squared. A squared would be 3q squared. Okay. So now every place I had an x up here, I've got a 4z. I had an x here, and I've got a 4z here. I had an x here. Wait a second. An x here, that's the 4z. I had an x here, and that's going to be here. The x was squared, so now the 4z is going to be squared. I had an x here, and there's the 4z. Then I had an a here. So there's the 3q. I had an a here. There's the 3q. And of course, I've got to include the 2. And then I have an a here. It's replaced by 3q. And it's squared for it. Okay? That makes sense? And then we can simplify this. 4z squared is 4 squared times z squared. Now 2 times 3 is 6, and 6 times 4 is 24. Looks like we should have 24. And then it's q times z. Okay. I think somebody got twice as much as they should have there, but take out y, you get 2 times 3 times 4. Those are the numbers. It might have been that you could do 2 times 3 and 2 times 4, but it doesn't distribute like that. And I remember doing stuff like that when I first learned this, so I had to get that straight. And then, well, let's see. So now we got, 3 squared times q squared. So we end up with 16z squared plus 24qz plus 9q squared. Now, if you get efficient with this, that's a lot quicker than trying to multiply 4z plus 3q times 4z plus 3q. And just to demonstrate that, we've got time. Okay, compare. Now, I'm writing this out kind of fast. But, I've chosen to do 4z times 4z plus 3q plus 3q times 4z plus 3q. And then I do my distributive law here. Then I've got 16z squared plus 12zq plus 12zq plus 9q squared. And I simplify that by adding 12zq's. And there I have it. So this is actually a little more writing, a few more steps, and this can actually be done more quickly than this can, especially when these expressions get a little more complicated. Okay, so there's a point to this special product. Even more important point to this special product is when we get to factoring, and we'll be getting into that next week. Okay, by this special product, I can look at this, and if I know how to look at it, I can see it's of this form. And I can identify that, well, x had better be the square root of whatever this is, which would be 4z, right? And a would be 3q. And this term matches up so that I can say that this breaks down to this. Okay. Now, you don't totally understand that. I'm just saying that there's something that's coming up next week where we try to identify whether this is of this form, and if it is, then we can write it out this way. And that's very helpful. Okay. Pretty important. Even though you never see it in the real world, it's pretty important for understanding some of the stuff you have to understand in pre-calculus. Yeah, so let's just look at a couple more examples. So we want to do y minus 3z squared. Okay. That's the square of a binomial. So we can use this formula, but we've got to understand that A, instead of being 3z, is negative 3z. Okay, so this is two y minus 3z is the same as 2y plus negative 3z, right? Is x plus a squared, but x is 2y and a is negative 3z. So if you have a minus here and it's squared, you don't confuse that with a x plus a times x minus a. That's not what it is, right? It's an x plus a squared where a is has a negative sign. Well, if we do the replace now, place x and a in this expression. So let me see you do that. I'm going to give you a minute because make sure you're staying focused on this. So write out for now. If you haven't written all this out, don't take the time to write all this out. You can copy it down later. You can take it off the video. Just write x equals 2y, a equals negative 3z. And you don't have to write the instruction, replace x and a. Just write this line, and then do the substitution. That's what it's not at this point. Okay, so here we have it. If we replace this x by 2y, we get 2y plus a, but of course we're replacing a by negative 3z. Now notice I keep the plus sign there and I put the negative 3z in parentheses. I don't skip a step here because it's a negative sign. And if you got a negative sign, it's very likely that in any significant set of problems, you're going to make at least one mistake. Okay. So you do everything you can to avoid making mistakes with negative signs. So we replace very literally. Here is the expression. Every plus sign is going to go in, and every a is going to be replaced by negative 3z. Don't bypass any of that. Okay, now the next thing I got is an x, and that's going to be replaced by 2y. And replace, again, remember, we're squaring the whole blame thing. Okay, we're squaring x, and x is 2y, so we got to square the whole 2y. Then we got plus 2 times negative 3z, because we're replacing a by negative 3z. Now we've got an x, and we're going to replace that by 2y. Then we've got a plus sign. And here's where I saw a number of errors, okay? And this is the sneakiest one. I mean, this is a little bit sneaky, but this is really sneaky, okay? We do the plus sign, and then we do the negative 3z squared. That makes sense? That's clean. Every symbol is there. The only thing that's been changed is the x's have been replaced by two y's, usually with parentheses. We didn't really need the parentheses here. It probably wouldn't be a bad idea to go ahead and use parentheses anyway. So we can clearly see that this is a replacement, this is a replacement, and so forth. Okay, so we get then, now simplifying 2y plus negative 3z, that is 2y minus 3z. And don't do like I did and some of you already have. Leave the square off of this thing. Said we had everything. We didn't include the square, did it? Okay. So I was busy looking at something else. Got to be careful about that. Okay, we got the quantity 2y squared. So that's 4y squared. Now we have 2 times negative 3, which is negative 6. Multiply by 2, we get negative 12. We usually write that alphabetically y, z. But since this is the order it occurred in, I'm going to leave it the way it is. Then if I square negative 3, I get a plus 9. And there's where the most common error comes in. It's real easy to get a minus here. If you're the least bit careless, that'll crop up, cause you to have an incorrect expression. Then we could write out, this is a final step, make it as grammatical as possible. Put the zy in alphabetical order, yz. So that's the process. Well, we've got time to do at least one more. So that will be visible. Let's try. This. Now that, as you probably recognize, is this form. We haven't done anything with this form. We've been using this. Okay. But what are we going to do with this? Well, what you want to do is identify what x is going to be, what a is going to be, write this out, and then do the substitution. See if you can do the whole thing. Okay. So what we have is this times this. We see that this is the same as this. This is the same as this. We got this minus this, and then this plus this. And that's in the form x minus a times x plus a, which we know has to be equal to x squared minus a squared. So for x equals 5p and y equals 3q, we get, writing this whole thing, x is 5p. Is 3q. Again, x is 5p. A is 3q. So this side is just what we have here. So this side is going to be x squared X is 5p, so we have 5p quantity squared minus a squared minus quantity 3q squared. Of course, then we can square this. That's 5 squared times p squared minus 3 squared times q squared, which is 25p squared minus 9q squared. Okay. And we're a minute over, so we're going to quit. So that's your assignment. Take the test and get this one assignment done for Monday. Let me know if you have questions. I'll be glad to answer.